Hi friends, welcome back on another video of unsupervised learning. So in this video we will do hands-on on linear discriminant analysis, right? So basically the objective here is to visualizing high dimensional data using the PCA and doing dimensionality reduction to check the explained variance using PCA model. So basically we will be training a linear discriminant analysis, that is LDA model, to check if product has been shipped or cancelled, right? So this is again the basic problem statement. So this you can take it as a minor project, right? So here this is an e-commerce company. So the due to the COVID crisis and lockdown, right, this company is facing lots of issue from the deals, and the shipment teams XYZ has lots of product data where various shipping and sales details of each product have been mentioned. So xyz.com wants to find out which of the products has been shipped and which of the products has been cancelled to reduce customer escalation. So as a data scientist, we have to train a PCA model to visualize its a higher dimensional data, and we have to train in LDA, that is linear discriminant analysis model, to predict which of the product has been shipped and which of the product has been cancelled. Now let's do it by one. So first we have to import a necessary library. So again we are importing warnings, right, to suppress all the warnings in this Jupyter notebook. Now we are importing numpy, or regular expression, pandas, right, scipy dot stats for statistics, and pyplot for plotting graphs, seaborn for visualization, factorial f, right, from maths, RC parameters from PayLab, right, and then we are importing our train test split from model selection, right. Then we have our classification reports, confusion matrix, ROC curve, accuracy score from our matrix. Then we have font properties, that is font from font manager. Then we have decision tree classifier from tree. Then we have random forest classifier from ensemble. Then we have standard scalar from pre-processing, right. Then we are importing linear algorithm, okay. Then we are importing decomposition, and finally of course we are importing PCA, but here the LDA, that is linear discriminative analysis from discriminant analysis, right. So this is the main thing in going to be in this video. Now displaying a sample of 5 rows of the data frame. So again df equals to read CSV. So here sales data sample.csv, right, encoding unicode escape, right. Now df dot sample, so we are taking sample of 5. So here you can see that 5 random sample that we are getting from our data. So order number, quantity order, right, and the CSV with the other attributes. Now third step is to check the shape of data, number of rows and columns, check the general information about the data frame using dot info method, right. Now defining basic information, df. So basically this function is checking basic information and shape about the data frame. So temp equals to df dot copy, df equals to true. Printing shape of the data, df dot shape, right, printing asterisk 30 times, df dot info. So basic info if we get, so here you can see that the known null values that we have is listed here. Now checking the percentage of missing values in each columns of the data frame. So here df defining check missing values, df, right, function to check the missing data percentage. Now printing percentage of missing data of data frame, right, df dot is null dot sum divided by length, df multiplied by 100. Now checking missing values, df. So here all these missing value that we have, the percentage you can see. Now here we can see the column address line 2 has 89.3% of missing values, state has 52.6% of missing values. Similarly postal code has around 2.69%, and territory has around 38% of missing value. Now we will drop the address line to column and impute other columns with most occurred values with the respective columns, right. Now checking if there are any duplicate rows. So defining check duplicate, df duplicate equals to df of duplicated, right, returning the duplicate here. Now duplicate equals to check duplicate df, right, and again calling the duplicate. As we can see, there is no duplicate columns, which is good thing for us. So write a function that will impute missing values of the columns state and postal code territory with its most occurring label. So defining impute most occur df, so df equals to df dot copy df equals to true. Now temporary state, we are getting df state value counts dot index, right. Now df state dot fill na, filling the na values with the value equals to temp state and emplacing true for permanent. Now df postal dot code, so another column, we are taking df of postal code, counting values and getting the index 0. Similarly for df coastal, right, filling the na, and same thing we are doing for this territory, right. So again temp territory equals to territory dot value count dot index 0 and taking df territory dot fill na, right, and value equals to temp territory in place equals to true and returning final dfa. Now df equals to impute most occur df, checking missing values df, calling the function here, that is this one, right, and printing asterisk 50 time, getting the basic info. So again we'll confirm that this is basically a function that is using or imputing missing values, right, with state, postal code and territory with its most occurring labels. So here you can see this is the missing values that we have, and when basic info.df we called it, right, we called our main. So here you can see first these were the missing values, right, this time it is zeros, and these are the main values. Now eighth is convert the label of the status column to 0 and 1 for shipped assigned value 1, and for all other labels that is cancelled, resolved, on hold, in process, dispute, assign 0. Now we have to note we will consider everything apart from shift as cancel, that is 0. So df status equals to df status map, so we are mapping it with the shaped 1, cancelled 0, resolved 0, on hold 0, in process 0, dispute equals to 0, right. Now df status dot value count, so 1 is 2617, 0 for 0 it is 206, right. Now assign status column into a label variable and drop it from the original data frame. Now convert the original data frame to the dummy coded data, and the hint is use pd dot get dummies, right. So here basically first we are accessing the status column. Now df dot drop, so status we are passing here, access equals to 1, in place equals to true. So new df equals to pd dot get dummies df, okay. So new df dot shape, if we check this, so 2823 with 645. Now use standard scaler to scale the data. So standardized data equals to standard scaler dot fit transform with the new df, print standardized data dot shape, so 2823 by 645 we are using this. PCA for visualization, now take the help of PCA to reduce the data to 2 dimensions, use n components equals to 2. So here as clearly mentioned that now sample data equals to standardized data, right, and PCA we are getting the PCA here. Now PCA dot n components as suggested equals to 2, PCA data equals to PCA dot fit transform, right, sample data. So here we are printing the reduced dimension, so this time you can see 2823 by 2, but last time as we have seen that 2823 by 645. So you can see the difference here, right. Now take the first and second principal component and plot a scatter plot with the labels. So here normally we have to plot the scatter plot. So PCA data equals to np dot v stack PCA data dot t, right, lv dot t. Now PCA df equals to pd data frame, data equals to PCA data, columns equals to first component, second, and then labels. Now SNS dot set grid, right, PCA df u equals to labels, size equals to 10 dot map. So plt dot scatter, first component, second component, add legend, right, plt dot show. So here you can see that we are calling this the scattered one here. right? So you can see the scatter plot with respect to these labels 0 and 1. This is the second component, this is the first component, right? Now it is asking write the intuitions about the scatter plot. So basically what we just got from here, so most of the data are overlapping with each other. So here you can see that 0 1 0 1 here as well, right? So these are nothing but overlapping. Okay, as we can see, datas are coming from cluster. Of course these all are coming from all these clusters, different. Now PCA for dimensionality reduction, so we have to apply that. First is fit. So these are basically the steps, so we need to keep in this mind. So we have, that's why we have written all these steps to get a better idea, or to follow a particular steps. So fit the PCA model on the data and plot a graph between n components and cumulative explained variance. Now PCA equals to PCA function we are calling PCA dot n component 645. PCA data equals to PCA dot fit transform, we are getting sample data from here. Now percentage where explained, PCA explained variance divided by np dot sum, right? PCA dot explained variance. Now come variable explained, so equals to np dot come sum percentage variable explained. Now plt dot figure 1, figure size equals to 12 by 8, plt dot clf, right? Plt dot plot we are calling come variable explained, line width equals to 2. Now plt dot axis we are calling tight, right? Plt dot grid here, plt dot x label is n component, right? And plt dot y label is cumulative explained variance. If we show our PLT, so here you can see that this is the n component and this is the cumulative explained variance, right? And you can see that here it is clear showing that around component, right? And this is 100, right? This could be our 200, okay? And around 100, between 100 and 100, it is achieving 90% of variance, right? So here again you can see that it is also stating from the above diagram, it is clear that taking around 150 components we will be able to get 90% of variance, right? Now let's start doing with linear discriminant analysis, and that is LDA. So the first step is we have split the data set into two parts, that is 80% train and 20% test using a random state, that is equals to 42. Importing warning dot file filter warning, that is ignore. Sample data dot shape, right? LV dot shape, if we get that, so 2823 645 and 2823. Now label equals to lv dot as matrix, lv matrix equals to label dot reshape, right? -1 to 1. X train x test, y train y test, we are getting a train test split, right? Sample data lv matrix test size, and that is equals to 0.2. Random state is also equals to 42, right? Now rf equals to random forest classifier, max depth equals to 3, and estimators equals to 25. Rf dot fit x train y train prediction equals to rf dot predict x train, y test prediction equals to rf dot predict x test, right? If we get the train accuracy, you can see here accuracy score y train prediction. If we get the test accuracy score is y test prediction. So we have star printed 50 times, then we are getting train confusion matrix from confusion matrix of y train prediction. Similarly for test confusion matrix from confusion matrix y test prediction. So here train accuracy and test accuracy, you can get the percentage value. So if we check the train accuracy, it is coming near 93%. For test accuracy 90%. If we talk about confusion matrix, so you can see 0154 and second is 02104. Similarly for test, right? So 052 and 0513. Now train a linear discriminant analysis LDA model on the train data, do fit transform on the train data and only transform on the test data. So if we check that import warnings, right? Again we have done this already. Now LDA equals to LDA and component equals to, we are defining as 1 x train LDA dot fit transform x train y train, and x test equals to LDA dot fit transform x test. Now x train we are accessing the fifth columns, right? And for x test also we are accessing the fifth column, right? So here you can see all these value that we have. Now train a random forest mode on the transform data and print the accuracy of train and test data. Now take maximum depth of 3 and n estimator as 25. So if we check that, rf equals to random forest classifier, max depth equals to 3, n estimator equals to 25, right? Rf dot fit x train y train prediction, rf dot predict x train, y test prediction, rf predict x test. Now printing train accuracy score, we are getting y train and y train prediction. Test accuracy score y test and y test prediction, printing asterisk again as 50 times. Similarly getting for train confusion matrix and test confusion matrix. So if we check that train accuracy and test accuracy, train accuracy is near to 95%, test accuracy is 92%. Now train confusion matrix and test confusion matrix that we got here. So if you check the difference between this one 0154 and 02104, and here 0 here you can see 88, 66, 39 to 065. Even the accuracy you can get that between 95 and 92%, but here it was 93 and 90% with the test and train. If we talk about some conclusion based on our LDA, so basically as we can see, true negative and false negative points is 0 before applying LDA, but after applying LDA we are getting some amount of true negative and false negative points. So due to class imbalance, the majority class has a high recall, but a minority class has poor recall. So this was all about the LDA that we have done the hands-on on. So we'll come up with the major project on unsupervised learning right very soon. So hope this series of USL did really help you and you are able to solve most of your queries. So if it is, do like, share and comment the video, and if it is not, so please do let us know what could we do to improve the content, right? So yeah guys, thanks for being with us. All the best, have a good time.